Hi, this is Professor Vivek. I'm a doctorate in supply chain management. I've been teaching for the last 22 years and I teach in the Decision Sciences department at PSG Institute of Management. In Module 1, we are going to be discussing how you can measure the performance of an entire supply chain. This will enable us to monitor and control the working of the whole supply chain as a single unit. Supply chain, it's a collection of entities which are working together to satisfy the needs and wants of the end customer. Now, how do you think we can measure the performance of such a vast group of entities which are all different organizations, but at the end they're all working as a network for one final goal? And why do you think we should be measuring their performance at all? What's wrong in the current setup where each one measures his own performance? Now let's consider two different supply chains in the milk industry. We consider two fictitious companies called Patley Limited and Camel. Which supply chain do you think would be a better choice for supplying milk? How do you think the supply chains can be measured? What information do you think each person should provide so that the entire supply chain performance can be tracked? How do you think the information should be collected and processed? What do you think will be the complexity of the computations? Who should be in charge of maintaining the score of the supply chain? Will it require expensive computing to monitor? Will it be practical to implement it at all? Will it upset the competitive advantage of the different players in the supply chain? Such questions have to be addressed with measuring the supply chain performance. Supply chain is all about measuring flows. Three major flows characterize the performance in a supply chain. These three flows are materials, information, and money. In some industries, flow of people can also be of interest, especially if it's a service industry like Disneyland or a hospital. So, any metric that aims to measure the performance of supply chain has to focus on these flows. There are many methods of tracking supply chain performance. We are going to consider one such method which stands out for its ease of application and availability of data. This was given by an Israeli genius called Eliyahu Goldratt. He suggested two measures, the TDD and the IDD. Goldratt proposed these two measures as a means to measure any supply chain's performance. We will be considering a slight variant of the original proposition by Goldratt. This is for convenience. The variation works as well as the original proposition. This video shall consider the first of the propositions, namely TDD. Goldratt used TDD to denote throughput days. In other words, if a supplier has delayed his delivery of a certain product, then we lose the opportunity to sell that product and earn a contribution from it. So, the price of sale minus the cost of the product is what we would have earned if the product had come on time. As a result of this delay, we have lost that earning. This is denoted by TDD. In other countries like India, we can use the term total value days because the rupee is the currency here. This is a measure of the lateness with which a player supplies any material to his customer. Now, let us assume I have to receive a consignment at 10 o'clock today. Assuming the value of this consignment is 50 lakhs and it is delayed by 3 days, the original measure would be only the number of days the consignment has been delayed. But Goldratt went on to say, and quite rightly so, that it's not just the number of days that's delayed, it's also the total value. Hence, the TDD is computed as the product of the number of days delayed with the value of the delayed items. So, in our case, let us assume the consignment is delayed by 3 days with a value of 50 lakhs. The total TDD here would be 3 days multiplied by the 50 lakhs, which is 150 lakhs. Now, the same thing would hold good if there is a delay after 10 days. Every single node having a delay should compute each and every delay using this same yardstick and note it down. The values are accumulated towards the end and they are taken stock of at repeated time intervals. Originally, Goldratt proposed a value known as throughput. Throughput is computed as the value of a stock minus the totally variable costs. Here we are going to neglect the variable costs and it would work just as well by talking of the sales value, not the cost value. Remember, here the value doesn't represent the cost value, it's sales value. Here we are going to have a look at the flow of value through the supply chain. Now let's consider a small example. This example talks about 3 players in a supply chain. A supplies to B and B supplies to C. Now if you see day 1, A is delayed by 1 day. His supply to B is delayed by 1 day. The delay in the value is 20 lakhs. So this means the total delay value happens to be 20 lakhs. That's the TDD. Now consider player B. If you take week number 4, he is delayed by 5 days while the delay value is 98 lakhs. Here the total delay value will be 98 multiplied by 5, that's 490. Now if you will note, the cumulative delay for player A across the 8 days is 778 lakhs. The same thing for C is 2340 lakhs. Note, we are not interested in the performance of one single player, A or B or C. We are interested in the collective performance of all the 3. Here, we collectively measure the total TDD for all the 3 players put together over the 8 days, and this happens to be 3514 lakhs. Now, supposing you are considering 3 different supply chains, this is a lovely measure to tell you which supply chain is doing better. Ideally, the total TDD should be 0, but in practice, it's never the case. TDD is also useful in identifying the bottleneck in the entire supply chain. In our case, if you would note, player B has a total TDD of 1174, which is another use for this particular calculation is finding the bottleneck in the entire supply chain. If you will notice in this particular example, player C has a total TDD of 2340 lakhs. This means player C is the bottleneck. He is getting delayed the maximum. So, if the entire supply chain has to do better, everyone should focus on player C. Now, can you see how simple this particular calculation was? But this is only half the story. What about deliveries that come early? We shall see that in the next video.